Okay, next page. We just did the product rule, so now we do the quotient rule. Things get more complicated when you divide. That's fairly common in math. Okay. So here I'm saying take the derivative of the quotient of the functions f and g. Okay. By the way, I didn't add to this, and probably I should have, where g of x does not equal 0. So how do you do the derivative of the quotient? Okay. Well, here I've given you a little mnemonic. I say you take the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, that's a mnemonic to remember this. There are others. I've heard nursery rhymes like low d high, high d low, square the low, and there you go, I think. But I don't remember that. I find it harder to remember the mnemonic than to remember the rule. So I'll let you can search, you can ask your friends, hey, what do you do to remember this? But you need to come up with something to remember the quotient rule. Okay? All right. So let me just show you how mine works. If we call f the top and g the bottom, then we would have the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the bottom function squared. Okay? So let's put this into practice. So I'll do this one with you, and then you guys can try 7 in your groups. Okay? So we're asked to find dy dx. The big picture when I look at this is I see a quotient. Okay? Sometimes, and I'll say this now, sometimes you can rewrite a quotient another way so that you don't have to use the quotient rule. But I think this is definitely a problem where you do need to use the quotient rule. Okay? So I'm going to go ahead and call, let's call f of x equal to x squared plus x minus 2. Let's call that the top. And then let's call g of x equal to 2x plus 1. Let's call that the bottom. So how do I take the quotient, the derivative, excuse me, how do I take the derivative of a quotient? The quotient rule says I'm going to first take the bottom function. So I write that out. Here's the bottom function. 2x, oops, how did I get that? Oh, I took the derivative, excuse me. Sorry, folks. I've got taken derivatives on my brain. I'm going to take the bottom function, which is x cubed plus 6. So I'm looking at the, sorry to make you flip pages, but I'm looking at that mnemonic that says bottom times the derivative of the top. So there's the bottom function. What am I going to multiply it by? The derivative of the top, which would be 2x plus 1. There's where that shows up. Okay. So if you're following along with the bottom with the mnemonic, we've got the bottom times the derivative of the top minus what? The top times the derivative of the bottom. So we've got a minus sign from the formula. Be careful with that, minus sign from the formula. So minus the top, what is our top function? That's just x squared plus x minus 2 times the derivative of the bottom, which is what?
3x squared.
3x squared. I'll go ahead and put plus 0 here again because we're just getting comfortable with this rule. Okay? All over the bottom squared. So I'm just recopying this since I can't quickly flip back and forth. Okay? So this is all over, what was our bottom function? X cubed plus 6 squared. Now, I didn't in this problem say do not simplify, but for one like this, I would probably not have you simplify it on a test. Just because I'm interested in whether you know the quotient rule and not having you spend a lot of time rewriting stuff. It would not be unfair to ask you to simplify this, right? All you would have to do is FOIL this out, distribute this 3x squared, collect like terms, and then just double check you can't cancel a factor in the denominator, which you probably won't be able to. All right, in your groups now, I'd like you to do number 7. And if you get done with number 7, move on to number 8. Try to think of 2 ways to do number 8. Folks, are there any questions on number 7 here? Okay, double check. This is definitely one that you'll have to simplify in my math lab, and it'll be a pain. Okay? I will not make you simplify this on an exam. Okay? All right, let's look at number 8 here. Okay? So the quotient rule is a very powerful rule, but it's also kind of clunky. Okay? So sometimes you can avoid using it. Okay? I'd like to do this first with the quotient rule, so we take d dx of 9 over x to the 5th. So using the quotient rule, I'd have the bottom times the derivative of the top. What's the derivative of the top here? 0, because it's a constant, right? Minus, don't forget that minus, it's often dropped. Okay. Minus the top times the derivative of the bottom, all over x to the 5th squared, right? You can say x, if you said x to the 10th, perfectly fine. Okay. So let's clean this up. I think this gives us minus 45 x to the 4th over x to the 10th, correct? But then I could simplify that one step further by writing that as x to the 6th power, right? Okay. Now here's I would not use the quotient rule on a problem like this. Okay, in fact, you tackled problems like this in 3.3 before you had the quotient rule. I would think that the best thing to do is to say that d dx of 9 over x to the 5th is the same thing as d dx of 9x to the minus 5. And now I get to use what on this?
Power rule.
Yeah, the power rule. So this would give me minus 45x to the minus 6. And then I take a step to rewrite it this way, minus 45 over x to the 6th. I think this way is a little more intuitive, but that doesn't mean that you shouldn't know how to do the other way. And so some people try to avoid the quotient rule like the plague. I would say no. Just when you're thinking you're going to use the quotient rule, ask yourself, is there quickly a way I could write this in an easier format? Okay. All right, go ahead and try number 9. Let's go ahead and take the derivative of this. And normally I think it'd be fun to kind of give you 10 minutes to work it out, but we just got to keep rolling. So I'm going to follow the sequence for the quotient rule. And so that's one thing you have to do in this problem is identify, is it a product rule problem or a quotient rule problem? The big picture is that it's a quotient rule. Inside of doing the quotient rule, you will have to do a product rule. Okay? So let's just stick to the script for the quotient rule. Okay? So for the quotient rule, it says you write out the bottom. What is the bottom function here? X squared plus 1. Now here's the part where it matters. Then we're going to multiply that by the derivative of the top. Okay, so let me put, so here's the b, and then we're going to take the derivative of the top. Okay? So what is the derivative of the top? Now we're going to do a product rule.
So we do the work like on the side? Are we working?
No, I'm just going to work it out of here. So how do I do the derivative of a product? It's the first times the derivative of the second plus the second times the derivative of the first. All of that is the derivative of the top. Okay? Okay. Minus the top function times the derivative of the bottom, which would just be 2x, all over the bottom function squared. The bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared.